Okay, we're going to be using part one of this lab to compare to models of the molecules we've been drawing Lewis structures for to figure out what the look of the molecule would be like as the atoms spread apart from each other, or the lone pairs of electrons push each other things away for the valence shell electron pair repulsion theory. So in part one, we looked at 12 molecules, and in this lab there are 12 balloon models of molecules that should match up to those 12 compounds. And if we've gotten the structures right and the AX codes right, and we figured out all the electron and molecular geometries, they should match to these 12 models. So here's model A. It's made of 6 balloons representing 6 electron domains. Okay, the blue balloons are here to show bonded atoms. Okay, and we are hiding the central atom in between all these balloons right there. Okay, so in your AX code, we are not showing the A part, the center atom part. We're just showing the X's and the E's, okay? So in this case, the blue balloons are the X's, okay? So this has 6 balloons, so it's gonna be AX6. There's no white balloons, which would represent pairs of electrons that are just hanging out alone on the center atom. So this would just be an AX6. You can go and find the electron geometry and molecular geometry for this on a VSEPR chart, and then compare it, and it should match up with one of the 12 compounds we did for part one of the lab. These are 2 other models that can be used to represent the electron and molecular geometry of your atoms in this compound here. Okay, so that's A. Let's look at model B. Okay, here's model B. You just have 3 blue balloons. Okay, you've also got other representations of the molecule here with the model there, with sticks, and the model here with the snatoms. This is model C. Okay, it's just 2 blue balloons, and again, the center atom is not shown, but it would be in between these 2. So you have one center atom here, then you have these 2 atoms bonded to it on either side. Okay, also represented by this snatoms model and this model there. This is model D. We have 3 blue balloons and 1 white balloon, so 3 bonded atoms, 1 lone pair of electrons. Okay, so our model might look something like this, where we have 3 bonded atoms and kind of a leftover space where you could have a lone pair of electrons that's pushing the other atoms in here away, but doesn't really have a space taken up for itself. We don't see it as an atom because there's no atom bonded there. It's just a lone pair of electrons pushing the other stuff away. Okay, this is another way we can model it, where the yellow here is representing that lone pair of electrons, and the gray is representing where your atoms would be sticking out on here. Okay, next up is model E. Okay, this guy is our model E. It has 2 blue balloons and 2 white balloons, so in total 4 electron domains. Okay, 2 of them bonded, 2 of them lone electron pairs. All right. Our model can also be represented like this guy. We've got these 2 bald spots here, and you've got this guy where, again, the yellow is representing lone pairs of electrons, and the gray is showing our bonded atoms. This is model F, where you have 2 blue balloons and 1 white balloon. You've got a snatoms model to fit it, as well as one of these models here. Again, yellow is a lone pair of electrons. Next up is model G. This is model G. It's kind of hard to see from this angle, but there are a total of 1, 2, 3, 4, 5 balloons here. 3 of them are blue balloons representing bonded atoms, and 2 of them are white balloons representing lone pairs of electrons. So you could model this in either of these 2 ways, okay, where you've got your 3 bonded atoms and 2 extra spots where your electrons are just hanging out and pushing things away. Or you could have something like this guy. This is model H. We have 1, 2, 3, 4 blue balloons to represent bonded atoms. Your snatoms model there. And your stick model there. This is model I. It's kind of upside down, but you've got 1, 2, 3, 4, 5 blue balloons and no white balloons, so only bonded atoms here. And you've got your snatoms model, which looks like this. And you've got your magnet stick model. This guy is model J. This one has 4 blue balloons, so 4 bonded atoms, and 1 white balloon to represent 1 lone pair of electrons. We've also got this model here to show that shape, as well as this guy. I always like the molecule shapes like this. Okay, last two. This is model K. We have a total of 6 balloons here. We have 4 blue balloons, and we have 2 white balloons. So a total of 4 bonded atoms and 2 lone pairs of electrons. It can look something like this, or like this guy here. And our last one. This is model L. We have 5 balloons that are all blue, that are your bonded atoms, and then we have 1 white balloon to represent a lone pair of electrons, also shown by this synonymous model here, as well as this guy here.